Hello, welcome back. By popular demand, enrichment in trigonometry. Just straight maths, no further maths required to do this particular question. Show that the sine of 10 degrees times the sine of 30 degrees times the sine of 50 degrees times the sine of 70 degrees is in fact 1/16. The question actually gave more clues, and I'll tell you where this question is coming from. Of course, it's in one of my special papers, but I'll tell you where I stole it from. First of all, there is a clue, so let me just write it in here. I didn't write it up there. Is by considering the double angle for sine, by considering the sine of 2 theta identity. And this particular question, I'll tell you where I stole it, is from a book from Hall and Knight. I have several of the books. These books were written in the late 19th century. I think I have the normal algebra, the higher algebra, and the trigonometry by these two authors. And I think the edition I've got is 1882. I could be wrong on this. Maybe it's the algebra that is that old one, and the trigonometry probably early 20th century. But it has some disgusting and amazing at the same time material stuff that is mind-boggling. Who on earth will be interested or be doing this kind of stuff? And a colleague of mine actually said this used to be sort of like books they used to use in schools maybe 100 or so years ago. It's very frightening. Okay, I have forgotten how to do this particular question, although I've done this in a lesson a few years back. So let's write the sine of 2 theta identity that we're meant to use to help us do this. So the sine of 2 theta is a very simple identity. It says quite clearly the sine of 2 theta is 2 sine theta cos theta. With stuff like that, you normally want it rearranged either for the sine or for the cos. So because I don't remember, it's going to be a little bit of a hit and miss. Do forgive me. Not pre-planned. So let's write in this particular case the sine of theta, because I've got sines. So this is the sine here, is equal to the sine of 2 theta divided by 2 lots of cos theta. Okay, so I'm going to use this version and try to rewrite now this particular expression, see if it works. So the sine of 10 times the sine of 30 times the sine of 50 times the sine of 70. So I'm using this line here, so that's my 10 degrees. Well, quite clearly that's going to be the sine of 20 divided by 2 lots of the cos of 10, and similarly that's going to be the sine of, we're doubling these numbers basically for the top, so it's going to be sine of 60 times the sine of 100 times the sine of 140 degrees, and on the bottom we got 2 cos, must remember to take this pen out. I think it's the same pen that I keep using and it keeps running out on me. 10, and then it's going to be the 30 cos 30, 2 cos. My brain is misfiring at the moment because I'm writing and I'm thinking not of what I'm writing but what I'm going to do next, because that doesn't look pleasant. So that is definitely correct. And just looking at what I'm trying to actually prove, that this is a sixth, sorry, 1/16, that's a half times a half times a half times a half. Somehow all these things are in fact ones. They will multiply to 1. Normally with things like that, the only thing I can evaluate directly is the cos of 30 and the sine of 60, but I can use complementary or supplementary identities. For example, the sine of 100 degrees, for example, is exactly the same as the sine of 80, if I had it somewhere so I can cancel it. But it doesn't look very pleasant. For example, here, this sine of 140, I could replace it with 180 minus 140 as the sine of 40, but I don't have things like that on my denominator. The coses can become sines, of course. Let me just show you how. The cos of 10 is the same as the cos of 80. Sorry, I beg your pardon. Again, I'm thinking ahead and I'm not paying attention to what I'm writing. It's the same as the sine of 80. I do apologize. That cos of 10, that is the same as the sine of 60. That is the same as the sine of 40. It can be done like this, I think. Let's have a little think about it in a second. And that is the sine of 20. So let me just proceed. This line, this quantities that I've got down there, I'm using the identity that the sine of A is identical to the cos. Can be verified by your compound angles, the cos of 90 minus A, and conversely, in fact, if you need it the other way around, the cos of A is the same as the sine of 90 minus A. So I'm using this on the denominator. It's an extra, not an extra line. These are just the denominators written differently. So I'm swapping just the cos of 10 for sine of 80 and so on. So let me just go a line or so ahead just to see if this works and what's going to happen. Otherwise, we can change plan. So this is going to be equal to 2 lots of the sine of 80 times, so we're swapping everything into sines by doing so. Sine of 60 times the sine of 100 over 2 lots of the sine of 40 times the sine of 140 divided by 2 lots of the sine of 20. Does anything cancel as it is in there? The answer is yes, it does. We can lose the sines of 60, that's gone, and we got the sine of 20 and the sine of 20. That doesn't look too bad, does it? And I think we're done actually. But I'll try to do it a slightly different way as well if I can. It's not guaranteed. We need now another fact. So all we left in here, let me just simplify just to see what we got left. We got 2 times 2 times 2 times 2. That's my 1/16 that I'm trying to prove. And what I've got left in there, I've got the sine of 100. We're all in degrees, so forgive me for not putting the degree sign, times the sine of 140 from there. And at the bottom, I've taken care of the 2's, of course. I've got the sine of 80 times the sine of 40. Of course, we got the fact about sines, and the sine, of course, let's use B this time because we use capital A up there, is of course, you should know this when you're solving trigonometric equations, and of course by the symmetry of the graph, it's exactly the same as the sine of 180 minus B. So that's sine to sine. This is sine to cos, cos to sine. It works with 90. So if you look at what we got in there, and this is game over really, is it doesn't really matter which ones we change. I'm going to change the ones on the top. So that's 1/16. Let's write the bottoms again. Sine of 80 degrees times of sine of 40 degrees. And the sine of 100, sine of 100 is the sine of 180 minus 100, which is the sine of 80 degrees. Okay, and the sine of 140, 180 minus 140 is in fact the sine of 40. And of course, boom, boom, equal 1/16, game over, we're laughing. I panicked a little bit up here, and I just, it might make the video a little bit long. I'd like to try a different, because if that wasn't going to work, what made me go forward, just to think a little bit about problem solving and what goes through one's mind, is the fact that I saw the halves there, and I thought that's 1/16. Surely there must be a way to show that what I've got left in there is in fact equal to 1, and of course it did work. But if that didn't work, or I couldn't see how to proceed, what I was planning to do is the following. I've got this line up there. I'm going to change it. You see this identity, I wrote it as the sine of 2 theta as 2 sine theta cos theta. We could have actually written it the other way around. In other words, let me just show you. We could have written it as we got the cos of theta is equal to 2 lots of the sine of theta, which is a little bit bizarre. But there's something else I'm going to do first for this particular one, and I hope it works, just to show you everything fits in mathematics and there's no exceptions. We might need some of this identity, so I'm leaving them up there. I'm going to, because I've got cos theta is equal to, I'm going to swap everything up there into coses. Okay, so my next line, the sine of 10, I'm not using this identity, I'm using this identity here. The sine of 10 is the same, I'm writing sine there stupidly, and I'm going to confuse myself, that's the same as the cos of 80. Make sure we can see where this is coming from. I'm using sine of A is cos 90 minus A, so sine of 10 is the same as the cos of 80. The sine of 30 is the same as the cos of 60, the same as the cos of 40, and the same, of course, as the cos of 20. Now I'm going to jump to this identity and let's see what happens now. This is equal to the cos of 160. It will work. It's exactly the same thing. I'm just doing things. I just realized what is happening there. Quite stupid. But let's see. Let's complete this. I started writing it now. So the cos of 80 is the cos of 160 divided by 2 lots of the cos of 80 times the cos of 120 divided by 2 lots of the cos of 60 times the cos of 80 divided by 2 lots of the what am I writing? I'm writing wrong there. I do beg your pardon. This is actually not correct. I'm writing stupid things. I'm getting very absent-minded. Okay, let's go back one step. I do apologize. Not pre-planned, as you can see. This is me, king of mistakes. I'm using this identity. Let me just put in a box. Sorry about that. Cos of 80 is equal to the sine of 160, double your 80, divided by 2 lots of the sine of 80. In fact, I was thinking, you probably cannot hear it in the video, a car alarm is going outside. I was thinking, is that my own car alarm, or somebody stealing my car, or is it somebody else's? Okay, so let's go back. Let me get my concentration back. 2 lots of the sine of 60 times sine of 80 divided by 2 lots of the sine of 40 times, we got, of course, the sine of 40 divided by 2 lots of the sine of 20. That's definitely exactly the same. And now we need to cancel some stuff. We're going to use now, again, I did say this is not different. In fact, probably the better way was the one I've done, which is against perhaps common sense, but it does work. And this is exactly the same, just reversing the steps and these identities. If you look now at the sine of 160, for example, it's exactly the same as the sine of 20, which appears some on the denominator. The same way, the sine of 40 will cancel directly there, so it's the sines of 80, and the sine of 120 and the sine of 60 are exactly the same. So let me just write them in red pen above them as to what is going on and then cancel them. The sine of some of the big numbers, the sine of 160 is the same as the sine of 20. 180 take away 160, so I will cancel that, so this will be gone. The sines of 40 will cancel naturally. The sines of 80 will also cancel naturally, and then we got this too. Do they cancel? Of course they do. The sine of 120 is of course the same as 180 minus 120 is exactly the same as the sine of 60. So if you see now, I'm not going to be writing all the workings. It's going to be half times half times half times half, 1/16, and then we've got sine of 20, sine of 20. The 2's of course I took care of. The sine of 80 and the sine of 80 gone. The sine of 60 and the sine of 60 gone. Sine of 40 and sine of 40 gone. 1/16. Take your pick. I know I've made a bit of a mess, lost my concentration at several places during this lecture. It's been a long day, but I hope you followed what is going on. This is just a little bit of fun. It's not anything that you likely see in an exam. Quite clever and quite nice, I like to think. Okay, I'll see you very soon. Who's laughing now? At the end, I managed to laugh.